Hello everyone, I hope you all are doing great. So today we are going to discuss very important and interesting topic in chemistry that is related to the isotopes and their masses. You have already studied about the protons, electrons, neutrons, nucleus and atoms. So today we will see how the atoms of the same elements can be different from each other, how the atoms of the same elements can actually slightly different from each other. So without wasting any time, let's get started. Today our main topic is isotopes and their masses. Isotopes and their masses. Masses means the weight of something. Mass means the weight of something. So the lesson we are studying is taken from page 24 till 25 from our textbook. Kindly check it out. So let's begin. What are isotopes? What are isotopes? Atoms of the same element. Atoms of the same element that have the same number of protons. That have same number of protons but different number of neutrons. The atoms of same element that have same number of protons but different number of neutrons, they are called as isotopes. They are called as isotopes. So the atoms of the same element that have same number of protons but different number of neutrons, these are called as isotopes. So let's understand the concept of isotope with the help of an example. We are taking the example of the carbon atom for the better clarification and understanding. So carbon has three isotopes. Carbon has three isotopes: C12, C13 and C14. Let's see, they all have same number of proton, 6, 6, 6. Where the difference come? At the number of neutrons. Carbon 12 have 12 number of neutrons, carbon 13 has 13 number of neutrons and carbon 14 has 14 number of neutrons. In this way, the atoms of the same elements can slightly different from each other. For example, carbon 12 has 6 protons, we know that, and 6 neutrons. 6 protons and 6 neutrons. Carbon 13 has again 6 protons, but where the difference come in the number of neutrons? They have 7 neutrons. Lastly, the last isotope of carbon is carbon 14. Carbon 14 has 6 proton again, but the number of neutron is changed here. They have 8 neutrons. So in this way, isotopes or the elements of the same atoms are slightly different from each other. Carbon 12, carbon 13 and carbon 14. They all are the types of carbon. They all are carbon because they contain the same number of proton. And the number of proton in carbon is 6. And that is the atomic number of carbon as well. But they are slightly different from each other due to the number of neutrons. So all of them are carbon because the number of proton 6 is the same in thrice of them, but they're different in mass. The mass is changed due to the different number of neutrons, due to the extra number of neutrons in each isotope. Let's move to the right hand side of the whiteboard. We are taking one more example of hydrogen for the better clarification and understanding, right? So hydrogen has three isotopes. Protium, deuterium and tritium. These are isotopes of hydrogen. So let's see, they all have same number of protons. The number of proton in hydrogen is 1 and the atomic number of hydrogen is also 1 because atomic number is equal to the number of proton. But where the change comes? At the number of neutrons. Protium has 1 neutron, deuterium has 2 neutrons and tritium has 3 neutrons. Okay? So isotopes are like siblings. They belong to the same family but slightly different weight. but slightly different weight and different physical properties, right? Students, it's time to dive into the next main topic, that is related to the properties of isotopes. What does it mean by properties? Properties are features of something, properties are characteristics of something. Okay, so let's talk about the properties of isotope. Now an important question comes: why the chemical properties of isotopes are same but the physical properties of isotope are different? Why the chemical properties of isotopes are same and why the physical properties of isotopes are different? So answer is that because isotopes have different number of neutrons, due to the different number of neutrons, their mass will change, and this affects the physical properties, physical properties like density, color, stability. We had been discussed about the chemical and physical properties in the previous lessons as well, right? So what is the answer? The answer is that because isotopes have different number of neutrons, due to the different number of neutrons, the mass of isotope will change, and this affects on the physical properties, That is the reason the physical properties of the isotope are different, but the chemical properties of the isotope are same because they depend upon the atomic number. And we know that the number of protons in each isotopes are same. Due to that, their chemical properties are same as well. For example, deuterium. Deuterium, that is the isotope of hydrogen. That contain two neutrons. We know that. Deuterium is heavier than protium. Deuterium is heavier than protium. Why? Because protium has only one number of neutron and deuterium has two number of neutrons. That's why deuterium is heavier than protium. So in this way, the mass of isotope change because the number of neutrons are added in each isotope form, right? So dear worthy students, it's time to discuss about the last content of the day, that is radioactive isotope. Radioactive isotopes. So what are the radioactive isotopes? Some of the isotopes are highly unstable. Unstables mean they are not in the form of stability, they are not in balanced form. So most of the isotopes are unstable. The question is that why they are unstable? Because their nucleus have too much energy. So the nucleus of these isotopes release energy in the form of radiations. That's why we call them radioactive isotopes. To the next heading, move to the next main point, that is radioactive decay. What does it mean by decay? Decay means the breakdown of something. The something splits into smaller units. It's the decay. So let's talk about the radioactive decay. So most of the radioactive isotopes give out radiations and they change into another elements. Most of the radioactive isotopes release radiations and they change into another form of elements. Just for the sake of example, for the better clarification and understanding, we will understand with the help of example. We are using uranium 238. When uranium 238 decays or break or split, they form thorium. They convert into thorium. Thorium is another form of element. It is another form of uranium. And thorium is break down into another element. Until it becomes stable. So radioactive elements are break down and convert into the new elements until it become stable. So this phenomena is radioactive decay. This phenomena is known as radioactive decay. So dear students, that's all for today's lesson. I hope you found it easy and understanding. You getting it well. So Keep revising and stay safe. Meet you in the next video lesson. In the next video lesson, we will talk about the applications or the uses of isotopes. So that's all. Stay safe. Allah Hafiz. Have a great day.